So you probably remember several periodic trends from general chemistry and your other chemistry courses. So these include, again, like we talked about in the first video, atomic number, and also atomic mass increases as we move from left to right and up to down on the periodic table. But also very important properties of the atoms have trends across the periodic table, including ionization energy, which is the amount of energy it takes to remove an electron from an atom, electron affinity, which is the favorability of an atom taking an extra electron, atomic and ionic radii, which are the radii of either the atom or the atom as in an ionic state with a charge on it. And also we can predict, for instance, stable ionic charges from the periodic table. And so for instance, if we look at the atomic radii of the elements, right, as we move across a period, you might recall that the radii, or the radius, decreases across a period. And then as we move down a group, the radius increases. All right, and so we're going to eventually discuss, right, why this occurs in terms of the interaction between the nucleus of the atom and the electrons in the atom. We also can, using some more by refining our knowledge of atomic structure and also electron configuration, we can look at discontinuities within periodic trends. So for instance, we see in this table that shows trends in ionization energies for atoms, we see that generally the ionization energy, for instance, increases across the period. However, if you look at certain parts of the periodic table, you'll notice discontinuities in this trend. For instance, the ionization energy from boron to nitrogen increases, but then between nitrogen and oxygen, it decreases, and then begins to increase again as we go from oxygen to neon. So there's not a sort of like this continuous trend across the period for increasing ionization energy. There are these discontinuities where the ionization energy will decrease between two atoms. And so how do we explain that? And so we need to, again, understand more about the electron configuration and the atomic structure and the interaction between the electrons and the nucleus. And so for the next few videos, we're going to reset and look at the basis for how we're going to be able to explain these periodic trends. And so we're going to start from a place that maybe may not make a whole lot of sense, but it will by the time we're done with this. We're going to start by looking at light and its properties. And then from there, we're going to move on to looking at the Bohr model of atomic structure, right, and the strengths and the weaknesses associated with that particular model. From there, we're going to look at the electron wave function, which will tell us more about how the electron is distributed around the nucleus in terms of looking at Schrodinger's equation and what that can tell us about that distribution. Then we'll look at how a one-dimensional wave function changes with a quantum number n. And then, since we are going to work in this class largely of course, in the three-dimensional, with three-dimensional wave functions, we're going to move up and look at the different properties and the different distributions that we find by looking at the three-dimensional wave function and the radial and the angular components of that, and then the quantum numbers associated with that. And then we'll move back to electron configurations, where we reintroduce a topic that you've seen in previous classes which is the Aufbau principle, and understanding why the energies of the orbitals are the way they are. And then we'll come back and put everything together that we learned and revisit the periodic trends in the context of everything that we discussed.